Hey, welcome. I'm glad you got this far. This is in the unlisted video section. This is where I put videos that would probably get taken down by YouTube. So we're actually getting around the censorship. That's what we're attempting here. So if these videos go down, the backup is going to be on Odyssey. That's where you can find all these. Anyway, why don't you come on into the lab over here and let's get set up. Let's talk about detonators. Come on in. And don't mind these ducks. I've got some little baby ducks over here brooding. Not a big deal. They shouldn't make too much noise, hopefully. Do make sure that you wipe off your shoes when you come in. We got to keep a clean house. We are in the lab. We're going to be talking about detonators today. So we're just going to set up right over here, and I'm just going to make some detonators exactly how I make them. I make a lot of detonators, and they don't fail. And the detonator, in terms of the technological function of an explosive train, is the most critical component. You don't have a detonator, you don't got
capability.
So this is what you have to get right. So I'm not an explosive expert. That's those are terms that you guys use. Okay, I didn't even finish high school, but I've made a lot of detonators. So if you want to make detonators that don't fail up from commercially available products that you can purchase with your own money as a civilian, this is going to be a guide for you. There are a plethora of moral, entanglements with any topic of teaching explosives, right? Of course, the wrong people could get it. Of course, it could be misused. It will be misused, right? But if you hadn't noticed, the seams of this dress might be coming apart here. So my angle on it is that my responsibility to my countrymen is to make sure that I serve the function of the Second Amendment, to strengthen it for you, my fellow militia. And that's what this is all about. This is how I serve my country for real. It's just like firearms. If you teach somebody firearms, of course, the information could be misused, right? But the fact of the matter is that Green Berets teach enemy combatants in combat to fight, and then they fight us later. And that's been going on for a long time. So this kind of stuff it's really quite innocuous, but critical information that we would need if we needed to use it in warfare. In unconventional warfare, this is going on all the time. This is going on in Eastern Europe right now. So if you need to come up with your weapons for knocking out tanks, for fighting infantry, this is a viable topic, and that's why they don't want you to know it. It's important information to have, and it's really not critical data. I mean, terrorists already make bombs. Terrorists already make detonators. This isn't anything new to them. It's new to you, my viewer. And I want to be the one to pop your cherry. Well, if you're worried about terrorists, maybe you shouldn't have voted to import a bunch of people that might be dangerous and might be terrorists. Maybe that would be a good idea, to just, live in a society without people that are a threat to you. Is that smart? I don't know. But where I am, I'm out in the boonies here, so I don't have the same problems or issues or thoughts as people that live in California, because I'm armed and ready all the time. Boy, all of that being said, I've already done a video on detonators. It's a general overview. All of the safety concerns that I think are important are included in that. So if you're concerned about safety, if you're an idiot, if you're a careless person, explosives are not for you in general. But if you're concerned about the safety aspect, you can check out that video if it puts you at ease. I don't know. I'm not going to be covering that aspect. We're moving on past that. This is like a part 2, right? So there's no implied warranty. There's no, I don't take any responsibility for you blowing off your fingers or killing yourself, or it doesn't go boom when it's supposed to go boom. That's all on you. Okay, this is just me showing you what I do. So let's get into components. So the body itself of the cap. So we are using a PT100 cap. This is produced by China. It's available mass produced as a thermocouple housing. It just so happens to be the same dimension approximately as standard blasting caps. It's about a 5mm internal diameter, and you're going to get overall, in terms of the total length of what you can put in here, you're going to get 1.1 cubic centimeters on average. Depends on the manufacturer, the factory actually producing it from China. You always want to QC check all of your stuff. Make sure that the dimensions, I've ordered some of these that the dimensions been totally off. So it just depends on the batch. Anyway, you want the nominal 5mm inner diameter, and these caps are made out of a stainless steel. That means that they don't spark. Stainless steel is good, aluminum is good. You typically want to avoid, like unchromed ferrous metal that will make a spark. That is the case that we're using. Now let's talk about the header. So your header section, I typically, I guess my preferred overall There's going to be Tygon tubing, which is used for, it's like fuel tubing. So Tygon tubing, 3x5. That means that the internal diameter of that is going to be 3 millimeters, and the outer diameter of that is going to be 5 millimeters. So this is going to fit pretty well inside of the PT100 cap, and that's what we want, right? We want it to fit right in there. It's pretty snug, That's what you want. You can use any material, right? Practically any material. You got to check compatibility if you have some kind of obscure filler that you're using in your caps. But for most materials, fuel line hosing is going to work great. This is the standard hosing that's used on like weed whackers, chainsaws, that kind of stuff. 3 millimeter by 5 millimeter Tygon tubing. Now let's talk about what you're putting in the header, like what you're actually using. You're going to want to invest in some American Visco. Okay, this is the external diameter is approximately 3 millimeters. That's not what I don't know what it is, an 1/8 inch. I don't know. We Americans, we don't use metric system, right? I do, but Americans don't. That's commie shit. So this is American Visco fuse, and it's approximately 3 millimeters on the diameter. It's going to fit right in your Tygon tubing. That's if you need to do, time delay. This is what you want to use. Advantages of American Visco is that it's extremely reliable. I've never in my whole life had a trouble with American Visco. I cannot say that about, like Chinese fuse. I essentially won't use Chinese fuse on anything at all that's life-threatening. A limb or loss of life or loss of eyesight, anything like that, I will not use Chinese fuse. You want to be using American Visco. It's worth the price. You want to invest in it. Don't skip on that. It's also dimensionally sound for these detonators, so that's what you're going to want to use. So the second most common means of actuation with detonators is going to be electric initiation. Electric initiation is going to really open up the wide world of sports of, special purpose detonation, remote detonation, booby traps, landmines, IEDs, all of that stuff is going to be electric. So this is just a simple resistance wire, and these are produced in China. These are mass produced in China. They typically come with a plastic cap on the end. This plastic cap actually doesn't fit inside of a PT100. It's about the same diameter at the opening. That doesn't matter because we wouldn't want to use it anyway. We want to tailor our own header to use with the cap, and that gives you a lot of benefits, like you can make it waterproof if you want to. How should I describe these? So these have a pyrogen. It's waterproof, a waterproof pyrogen on the tip, and it works really well inside of a piece of Tygon tubing, and I'll demonstrate that when we, finish out a cap here. We'll do one electrically fired, we'll do one with time delay, you'll see the difference, we'll talk about it. They'll probably get banned eventually. There'll be a high profile incident and then they'll get banned. Business as usual. So we've got our cap body, what we're gonna be constructing this cap out of. Those are the commercially available components. Now let's talk about the other equipment that you're going to need to, successfully load a cap. First one's going to be a proper scale. I like to use this Perfin Chinese cheap scale. So then we'll talk about the cap charging station. The cap charging station is I've got an old piece of, rusted out oxidized lab stand with probably like a 1/4 inch rod in the center that would normally be used to hold glassware, and I'm using that with clamps, and I'll usually have two, and one of the clamps I will use to set the height on the loading funnel, and the other clamp I will use to hold the loading funnel. This is just extremely simple, stupid, simple, reliable stuff. That's what you want. So the loading block that I use is going to be standard, rough frame 2x4 pine, right? So this is a 2x4 sawn at 5 inch, so we've got 5 inch, then we've got a center hole approximately. So the center hole on my block is going to be wallered out. It's very important that your drill hole is plumb, meaning that it goes straight through both this way, but also this way. So that is the cap mold. That's what we're dealing with there, cap mold. So you have a few tools that you're going to use for the actual charging of the detonator. The first one is going to be your powder funnel. So a powder funnel, I use a 17 caliber RCBS funnel, a 3 millimeter approximately, it's probably more like 2.8 diameter stainless steel rod, right, 316. And then we've got a 316 5 millimeter. This would be like a dowel pen. Okay, so that's the equipment other than the press itself, which is an arbor press. It's a cheap Chinese arbor press, similar to like a Harbor Freight press. That's what we're pressing on. This is shielded, by the way, with ceramics, so bricks. I've got heavy bricks, 15 pounders. I've got some on the side, and then I put one on the front. The one on the front is supposed to stop, I mean, it's intended to stop something that would be like higher velocity, large mass, like a loading rod flying through the air. Then additionally, I got a polycarbonate shield. So it's just clear polycarbonate, 1/4 inch. I put that between the brick mass and the arbor press, and that's going to prevent light fragmentation from reaching you. Hopefully it'll help you a little bit. I set up the polycarb when I'm pressing just out of the way of the arm of the arbor press to clear it so I can pull it down. All right, so let's load a cap here. Let's just walk through the process so that I don't forget anything. I'll just, tell you what I'm doing as I do it. Single PT100 casing. I'm going to place this into the smaller hole, the more tight hole of the cap mold, right? So that's pretty tight. It's not going to fall through. The center hole is going to be a little bit wider, and this is for later. We'll talk about it. So I set up my cap mold on my loading station, put my powder funnel over the cap. We are now ready to charge. Now we need a material to charge, right? The filler that I'm going to be using is Petin, right? I would recommend Petin or RDX. In some cases, you may want to use TMTN, like an insensitive detonator, or one that doesn't require an extreme high impulse to detonate. TMTN is a great option. For most applications, I mean, you wouldn't have to go beyond RDX in terms of power. I mean, you can. There are some materials that you can get beyond that, but it's just not. I don't think it's realistic for a detonator video. A lot of people are not going to be doing that. 99% of people are going to be using probably ETN. ETN is a little bit less powerful than Petin. It doesn't kick as well for detonators. Petin has an edge, and RDX has an edge over Petin, and K6 has an edge over RDX. We are going to be using Petin. That's what I use for 99% of my tests. So we are going to weigh out. I'm going to do a 3/4 gram. So we're going to weigh out 0.75 grams of Petin on the scale. Okay, so out of 0.75 grams, I'm going to start to pour about 1/3 of it into the powder funnel. I'm not going to pour it all in, and then I'm going to assist it with that 3-inch stainless rod, pushing it down the funnel gently. And now this is the first output section of the detonator. So this should be highest density for highest power. So I'm going to press this pretty hard. Now when you press, you want to be slow. You don't want to be fast. If you go ramrodding this thing, that's where you're going to get a detonation. You just want to be slow and steady on your pressure, and you don't want to jerk it. You just want to press. All right, so I've got my cap mold on the press. I've got my brick mass in front of that to protect with a polycarbonate shield. We're ready to press. Kevlar glove goes on your loading hand. You're going to get some fragmentation in this hand if it detonates. And so we're going to start our pressing stroke. We're bringing down pressure with the arm, but I'm not using shoulder, and I'm not using my hips or anything like that. It's just arm pressure from the elbow up, pressing straight down gently. Now I want to show you something that I do on my arbor press. So this arbor press, the way I have it set up right now, with this cap in there, I've just kind of like maxed out on the throw for my lever advantage. So my lever is all the way down now. This is the reason that I take off the the locking limiter on the side of the press arm, is so that I can reset it. So that means that I'm pulling out like I'm seated right now on top of the cap, and I can pull the arm out, turn the arm upward, and now I can reposition it to get additional leverage to finish up a stroke, if I wanted more pressure. So that's about all I want. I don't want to do more than that. And that's pressed pretty well for an output section on a detonator. Okay, cap and mold has been removed, and we're now adding additional base filler of Petin. So before we did about 1/3 of that 0.75 grams. Now we're going to do about another third, and then we're going to leave a third. The last third is going to be lower density. So we're just going to press this again. I'm going to do that, and then we'll come back. And now we're doing the last third. So this last third is going to be pressed but light. It's not going to be, you're not going to muscle on it. You pack in your last third of your load, and you can load in as many stages as you want. The more stages that you do, the more consistency you'll have in your density for your base charge. All right, so now we're gonna do the last press. All right, so I'm repositioning my pressing arm for the new height with the additional material, slide my polycarb shield, slide my brick. All right, brick shielding's in place, and then we're gonna put on the glove. So now we're just gonna lightly press in, and there should be like a natural sinking of the rod, and then when that stops, you just stop. You don't need to apply much more because you want it to be pretty low density for your last section, and this is going to increase reliability when you go to actually fire this cap. So before you put in your electronic igniter header section, you want to test continuity. Just make sure that you have a a viable circuit here and that there's not a disconnection. All right, so now we're going to put the header on this cap. I'm going to use an electric igniter, so we'll do an electric and then we'll do a time fuse. For the electric, what you do is you remove the plastic that it comes with. These actually should be, at the end, they should be shunted by being twisted, right? That's why there's that missing insulation there. So these should be in contact, and that just prevents any, I mean, you're not going to have static or something come through here. But the shunting is to prevent stray current from like charged particles or something traveling through this thing. So have it shunted, and now what we're going to do is cut off a section of Tygon tubing. So it's approximately somewhere around, like 1 1/4 to 1 1/2 inch. I don't usually actually measure them, but that's approximately what it is. And then you put the back of your igniter through there, pull it up to the tip, and then just kind of sleeve it over the pyrogen, and you want to leave approximately 6 to 7 millimeters. I mean, it depends on your primary explosive. I'm going to be using NAP. That's what I use for everything. So we're using NAP primary explosive to charge this. And the volume that we're going to be charging this with is, it's a cylinder of approximately 3 millimeters in diameter, and we're about 7 millimeters deep. So the way that I charge that with NAP, you really don't need much. You're just going to just kind of press in your header section against a pile of NAP, and it's just going to fill it up. Now I take my 3 millimeter tool and I'm going to give it some compression. This just increases the density to make it fire harder. That gives us some additional volume to fill up, and we're just going to go back into the NAP, fill it up. Now we've got our primary explosive loaded into our header. Now you have a couple choices. You can cap this off. You can use a foil tape is what I use if you wanted to really seal this up. And the foil actually, in certain cases, the foil can actually, it can serve like a slapper charge if you have a space. That's kind of beyond this video. That'd be like an advanced detonator. Let's not talk about that. But just know that you can seal this if you want. For simple test detonators, like we're just doing this, we're just going to go fire these. It's not terribly important. We don't actually have to have it sealed. Now, one of the things that I'll mention is that in this design, the way that I do it, the primary explosive is separated from the base charge, which is extremely safe. So if you're in an operation like a guerrilla warfare operation or a war situation, you have soldiers dedicated to constructing detonators, this is a really safe way to do it because your method of actually causing a detonation is separate from your base charge, and you don't have to put it in there until you're ready to complete the detonator. Even then, it's pretty, like the Tygon is soft, so the body itself has some give if it gets crushed while it's in the detonator. It's just a lot safer than traditional detonator designs doing it this way. So for this one, I'm not going to seal it. I'm not going to put foil tape on there, but if you were using foil tape, use something like 1.5 mil thin foil tape. Put it on there. It's got to be pretty tight around there to make sure that it clears the cap. And so for connecting the header to the cap, in the cap body itself, in the mouth that's left open, there's some petting on there. I'm just going to wipe that off, clean it off. I've wiped off the outer edge of this to remove additional NAP from around the side. And then the last thing that I'm going to do is push through out of the tight hole. And we're going to put it into the middle hole, which is a little bit wider, just slightly wider. And the reason why is, if you can see that, this is mushroomed out a little bit at the tip. That just has to do with the amount of pressure that's applied in the arbor press, and that's pretty typical. So I put it into the middle hole, which is a little bit wider, and this is going to make, now be careful because it'll fall through, right? You want to make sure it doesn't fall through. This will hold it while I insert the header and crimp. So header goes in, you just insert, twist, and push down. Give it kind of like a turning motion, but not too much turn. You don't want to cause like a break in the electrical continuity or something like that, but you do want the header and the primary explosive to be up against your secondary explosive charge. And after you do a few of these, you'll get an idea for depth, like what it should look like to know when it's been fully seated. Once it's fully seated, now you have your choice of crimp. RG58, those are pretty nice. They look really good on a cap. There's also, if you want to do waterproofing, I would recommend the old mil-spec, military crimpers. These work really well to make a waterproof cap. So you pick a point on your cap. I'm going to do about, 2 millimeters down from the mouth opening. And I'm gonna wear a glove for this one, just in case. Okay, so what I'm doing now is I'm kind of turning my body away to minimize fragmentation. I have the military crimpers in place on the cap, and we're ready to crimp. And so I'm gonna look away and crimp, and we're good. So now I'll turn it 90 degrees. I'm gonna crimp again on the same circumference. Okay, so now we have a crimp cap. So this cap is now crimped. This is waterproof. The pyrogen in the head is inside the Tygon tubing in front of the crimp. It's crimped behind that, and you can get some water ingress in here, and it's not actually going to go through. I mean, typically, you'll have to validate that with your particular components if they're in a different dimension or something like that. But this is the idea of how to make it waterproof. Now, if you wanted to make it, this isn't waterproof like submerge it to the bottom of the ocean and leave a charge underwater for months. This means waterproof like, you can just put this in water, it'll still detonate. Your stuff's not gonna get wet. All right, so now we're gonna do an additional cap with time fuse American Visco. When you get your fuse section, you wanna do a test burn. So this is you pick an arbitrary length, typically 5 inches or more. You're gonna measure out exactly, you cut it. You typically don't wanna use a crutching implement like a pair of scissors. You wanna use like a razor edge, something like that, to cut it, and that's just to keep the surface area maximized for output and so that you don't lose black powder product from the inside of the core. The reason that you're cutting at an angle is because it's going to increase surface area to give maximum spit that shoots out of the end of the fuse when it goes off. So you cut a pre-measured length exactly to size, you write that down, and then you're going to burn it and time it, and that's going to give you a measurement of time per that length increment, like whatever you're using, inches, centimeters, whatever. From there, you can plan out the exact delay for your detonator, how long you want it to be delayed. Okay, so American Visco time fuse, we're going to insert the header. This is it's approximately, I don't know, this one's probably more like a 1.25 inches, but like 1.5 inches. If you can see that, we've got the angle cut right there, and I'm going to leave it around 7 millimeters or so approximately. So this corresponds roughly to 35 to 50 milligrams of NAP. That's sort of the standard charge that I use that always works. I don't want to go too light. I mean, you can go less than that, but I like to have high reliability, so I'll do 30 to 50 milligrams, something like that. That's what automatically fits into that space of cavity, and so I'm just pressing in my NAP onto the tip. This one we'll do like a waterproof cap on this one. So there's the tip. I'm gonna compress it a little bit with a 3mm tool. I've got some more room. I'll put some more NAP in there now. Push it down with the tool. It's flush. It's compressed in there. For this example, we'll seal it off just so you can see what that looks like. Aluminum foil tape. Tear it. Take off the backer and place it over the end of your header section. You can fold it over, or you can also hold it and then cut the extra off with a pair of scissors, and that just makes it easier to insert into your cap body, because that stuff can overhang on the side and kind of make it a chore getting it in there. It just depends on the particulars of your situation, but it can be a pain. So there we go. That's a sealed, practically sealed, and that foil will actually probably give some assistance in detonating. So then we're going to insert this, you wiggle it into your cap. Now you have a time delay blasting cap. This one's going to be waterproof, so we're going to use the military circumferential crimpers, and we're going to put at least a single crimp. You can do double if you want. You can do double crimp. I'm just going to do single. That's good enough. Put on my glove, turn my head, crimp. Okay, we're good. All right, so now we have a time delay blasting cap. So now we're gonna go into the application of these. We'll take them outside and fire them, show you what's going on with them. Okay, so we're getting ready to fire the electric cap. It's super windy out here. Anyways, what I'm doing here with the cap, I'm gonna stick the cap in the ground. I poked the hole with a crimping tool. You shouldn't use the cap itself to poke any kind of hole, either in a charge or like on the ground. Like I'm doing this for safety, right? This is gonna dampen any sort of accidental detonations. So I put the cap in a hole in the ground that I poked. Now I'm gonna take the leads off the end of the blasting cap, and I'm gonna unshunt them and connect them to the firing wire. Now I'm gonna take my blasting wire. This one's old. It's got some old wire on there from a previous blast. It's just totally fried. There we go. I'm just gonna twist those up a little bit. So then we got your blasting wire. You're gonna attach your wires however you want. This is just hand wound, but you can use any sort of attachment method. There's lots of high-speed ones like BNC connectors are really nice if you're using coax, firing cable. This cable that I'm using is like a military field phone wire. You can get it in 1 kilometer rolls, so that's why I use that. So then we've got the input side of your firing wire, and this should also be shunted. So you would unshunt it, you would disconnect it, you would open the circuit. Okay, so I'm going to be using a cheap Chinese remote firing device to fire this as a receiver. So I'm going to stick my firing wire into the receiver, have it all connected. These are kind of cool because you do have a continuity tester. That'd be the first setting. You see this go to green. That means that you have continuity, and then we're going to go beyond that to single on this particular unit. These are just cheap VHF remote firing units. I'm going to set that receiver slightly out of the way. It's on. It's ready to receive a signal. This is the remote. So I'm going to fire this from, I'm going to move back a couple of feet and we'll fire this off.